Okay, here you go. So we're going to begin our properties of proofs by looking at algebra properties. All right? And what I mean by algebra properties is one like this. So we're going to start with the addition property. Now, we can abbreviate in this class property PROP period. So let's go ahead and write that from every single time. So PROP period. When you are doing your proofs, or you're doing anything like that, you're allowed to put addition or abbreviations. So we're allowed to say that. Okay. And here's the addition property. So here's what it's going to be. So I'll switch to red. This is going to be a red pen. It's going to say this: if A is equal to B and C is equal to D, then we can say this: A plus C is equal to B plus D. Now that looks kind of strange when you look at it from left to right, but check this out. If I just did this, if I added these up vertically, what would I get if I added A and C together? And look, there it is. What would I get for B and D? What would I get? There you go, okay? If A is equal to B and C is equal to D, then if I add those together, they still got to be equal. That's the addition postulate for us. Okay? Next one. So if we have, I bet you can figure it out. If I said that A is equal to B and C was equal to D, then what can we say? If it's the subtraction property, subtract them, what would you get? There you go. A minus C has to be B minus D. Just subtract them vertically, right? A minus C has to be B minus D. So here we go. Property says this: if A is equal to B, then A times C has to equal B times C. So if you want to just consider multiplying each of these by C, there it would be AC has to equal BC. That's our multiplication property. Right? Division property says, okay, if A is equal to B and we are guaranteed that C is not a 0, and the reason C can't be 0 in this particular case is because in math you're never allowed to divide by what?
0.
By 0, so you can never do that. So if we know that A is B and C is equal to 0, then we can say this: then it must be true that A divided by C is going to be B divided by C, so long as what, everybody, again?
It's not equal to 0.
So long as C is not equal to 0. Alright, so for box number 2, we're going to start talking about other properties that aren't algebraic, but they're more like words and they look like something. So you have to be able to recognize these properties when you see them. So the first one is the substitution property. Now, anybody been watching the World Cup soccer? Okay, I mean, anybody ever play soccer? Or a sport? What happens when one person comes out of the game and another person goes in? What do you call that? A sub, right? I need a sub. So basically subs are what? What's a word that we could use them for subs? Replacements. I like that. Give me another word that's similar to replacements. How about interchangeable, right? Okay, good. So here's what we have. If you know this, if you know that A is equal to B, and this is my red pen here. If you know that A is equal to B, then A and B are interchangeable. Huh? Yeah. So if A is equal to B, then we can say A and B are interchangeable. Alright? So as an example, if I had 3A plus 5 was equal to 10, then what could I use for another line of algebra instead of A if I know that A and B are equal? What could I say? 3B plus 5 must also be equal to 10. It's the same thing. A and B are interchangeable. This is called the substitution property. And it happens when we replace one thing for another if the two things are equal. That's what that means. Alright, the next one in category of other, we had substitution property. We're talking about the reflexive property. And the reflexive property is so basic and simple. It says this. It says that A is indeed equal to itself A. When you look in the mirror, you see a reflection, and you are pretty much equal to yourself. I would hope so, right? It would be terrible if you looked in the mirror and saw half of yourself. That'd be terrible. Like, you know.
Well, it's a totally different person.
Totally different person, right? So I could say angle D is equal to angle D. I could say the measure of angle ABC, of course, is equal to the measure of angle ABC. Now you're wondering, like, where does this even come up? It does come up in our proofs, and you will see it later today. Okay. Okay, the symmetric property basically says this, okay? If you know that A is equal to B, two different things are equal to each other, then it must be true that B is equal to A. So what did I do there? I just read it which way? Backwards, right? It creates symmetry, right? If A is equal to B, then B is equal to A. So reading it left to right, and they're symmetric, means I can read it from right to left and still have those statements be the same. Yes, sir. Okay, transitive property. This is my favorite one because it's the most logically fun to do. Think about this. Okay, if A is equal to B and B is equal to C, then what do you think you can logically say from here? If you know that A and B are the same and B and C are the same, what can you say then?
A equals C.
There you go. Then A is equal to C. Transitive property allows you to get from one end to the other end of the statement, from A to C, using the fact that they're both equal to B. Okay, again, similar to substitution, right? Substitution will always work. Transitive works if you've got both things on both ends working for yourself here. So if A equals B, B equals C, then A is equal to C. That's our transitive property. So here is the category of other properties so far. We have substitution, we have reflexive, we have symmetric, and we have transitive. All right, so the last three here that in the category of other, we've covered segment addition and we've covered angle addition. Distributive, I'm pretty sure everyone knows a distributive if you've taken an algebra class. So distributive property would say this, A times B plus C, what would that have to equal? A times B plus C, what's the distributive property say? There you go. And then A, B plus AC. We're allowed to distribute our A to the entire expression of B plus C. All right, segment addition. Just to review it again, if I have a segment here, call this A, call this B, call this C. Segment addition says this, line segment AB plus line segment BC would have to equal what for the entire thing? Line segment what?
AC.
There you go, line segment AC. That's our segment addition. So the first segment, this segment, plus that segment equals the entire segment put together. It's the same exact idea for the angle addition postulate. Okay? Let's say I have this going on, all right? And I'll put some points on this line. So I'll call this A, I'll call this B, I'll call that C, and I'll call this D. The angle addition postulate says that this angle plus that angle there has to equal the entire thing this. So how do we write that down? Well, we would say angle A, B, C. That's this angle here I'm covering in. That's angle ABC. You guys cool with that part? Does that make sense? Okay. If I add to that angle CBD, this part here, angle CBD, what does it have to equal? The grand total of what? Angle ABD. So do you notice that angle addition and segment addition, they operate the same way? Does that make sense to you? So here's the setup of a two-column proof. You're going to be given some information over here, and you're going to be asked to prove some information over here. All right, or wherever it might be. Now, the idea of the two-column proofs is on the left-hand side, you are going to make general statements. All right? You're going to actually say something by writing it down. The right-hand side is going to give you the reason that you're actually stating it. Okay? So in geometry, we cannot say something without having a justifiable reason. So on the left-hand side, we will always have our statements. On the right-hand side, we will always have our reasons. Okay? And this is going to be our format for what we've been given here. Now, generally speaking, you're always going to start with, you're going to number them on the left-hand side. You're going to have number 1. And the first thing that you're going to write down is whatever the given statement is. Whatever that happens to be. This is how you get your free points here. Whatever the given is. Okay? Whatever this part happens to be. And the reason you get to write it down is because it's given. That's the actual reason that you get to write down. It's given. Then you're going to leave some space. And we're going to number it. And we don't know how many numbers it's going to take to get our proof done. How many steps in order it's going to take. So we're going to leave it blank. And then on the very last part here, on this side, we write whatever the prove part is. So the part that I have in parentheses is going to be this. So whatever the given statement is, you're going to write that there. And then whatever the prove statement is, you're going to write that part there. Alright? That's going to be our... Alright, here is the given and here's the proof. So we have been given, this is an algebraic proof, and we're going to use the two columns to sort of get ourselves in the right mindset. So we're given that 4x plus 17 is equal to 19, and we're trying to prove that x is equal to 3. And we're going to use the properties that we have discussed, all those algebraic properties, in this proof. So we're going to set up our two-column proof. Okay, so we draw our two columns. Over here we have our statements. And over here we have our reasons. And number one, we always write down our given. So what is our given here in this case? What's the given? There you go. So over here, this is what we do. We're going to write down what we've been given. We know that 4x plus 17, or sorry, not 17. Sorry, it should be 7. 4x plus 7, there we go, otherwise not going to work, is equal to 19. 4x plus 7 is equal to 19. Now, what's the reason that we can do that? Because it's given to us, right? So number one, it's actually given to us. We're actually allowed to write that in. That's the reason we can state that in our proof, because it's given to us. All right, now we're going to skip a bunch of lines. We don't know how long it's going to take. Okay, we're going to come down here, and we're going to write down the thing that we're supposed to prove. And the thing we're supposed to prove is this. X is equal to 3. All right? Sorry, it goes on the left-hand side, not the right-hand side. See up here? This part? It goes here. Sorry. All right. All right. Now, if you do all of this right here, ladies and gentlemen, this part, and this part, those are your free points. Free points every single time. Those highlighted parts right there. So even if you have no idea how to fill in the stuff in between, you do your free parts and then you keep going. Yes, sir. How many points do you think like this? Okay, now if you were going to solve this algebraic equation, if you were going to solve it, what would you do first?
Subtract 7 of those. No, you isolate the variable.
You isolate the variable. Yeah, what do you think?
Subtract 7.
Okay, subtract 7. So here we go. The second step that we would do, we actually write down the result. So we would say this. We'd say that 4x is now equal to what? It's equal to 12. So we'd write down the result of what we did. Now, how did we get from 4x plus 7 equals 19 to 4x equals 12? What did we do?
7.
We subtracted 7. So what allows us to do that? Can we go back and look at our properties? Which algebraic property do you think we used? I'm thinking it's that one right there. You guys cool with that? Does that make sense? Okay, that's what we did. So let's go back. Yeah, you got it. Exactly. So over here, number 2, we're allowed to say this. The subtraction property. Subtraction property. And actually for us, since subtraction and substitution have the same 3, we're going to have to write out the words. So we're going to put subtraction. But you can always do prop. Period. That's the subtraction property. Okay? Now, what would you do next?
Divide 4.
Divide by 4 on both sides. And what would you end up with?
X equals 3.
Oh my gosh. So that must be the third step. Check it out. X equals 3. We always write the result of the action, right? So now, what allows us to do that? What do you think? The division. That one you can abbreviate. So, in the given, you're given that 5 times x minus 1 over 3 is equal to 10, and I want you to prove that x is equal to 7. So what's the very first thing that you're going to do, you guys? Write the given, give me the reason, and then skip a bunch of space, and then write down the thing that you're supposed to prove. So it should look like something like this. Okay, this right here, this is how you should have started, right? Does everyone have their free points down? Do you have this right here written? Do you have that? Do you have this part over here, numbered number 1? Do you have some space down here and then the thing that you're supposed to prove right there? That right there, those are your free points, okay? All right, do you guys want to try this one on your own? All right.